Hello, scientists. In this video, I'm going to review and reteach a number of key Desmos graphing skills, including putting labels on your X and Y axes, adjusting the scale of each axis so all of your data can be seen, and 3, using the A slider to identify a line of best fit and an equation that best matches your data. All right, let's get started. Here's what you can see so far. This is a partially completed Desmos graph showing distance and time data for a car driving down Lombard. The distance the car traveled was measured every 5 seconds for about 30 seconds, and that data is shown in the left column in the little data table. The T stands for time, and the D stands for distance. But if you look at the graph, you can only see 2 of the points, and there are no labels on either axis telling you what the variable is and what the unit used to measure the variable was. So to fix those 2 omissions, here's what you got to do. Take your cursor and you go up to this little wrench and you click on it to open the graph settings window. Down in the bottom half of the window, you see a little check mark by x-axis and a little check mark by y-axis. This is where you both label your axes and adjust your scale or the range of numbers shown on each axis. So for the x-axis, we want to, in this box where it says add a label, identify the variable graphed on the x-axis and the unit used to measure that variable. So if we look back on the left column, on the left side of your window, you can see that the X is time. And we measured time in seconds. So in this little box, you just type in time in seconds. Okay? And the same thing for the Y-axis here. The Y variable is distance, and in this case, we measured distance in meters. Below that, for both the X and the Y, you can see the X variable and the Y variable with greater than or equal signs and numbers on each side of the letter representing the variable, okay? So right here it says X goes from about -2 to 25. What that is describing is the numbers that are shown, the numbers you can see on that X axis. And we have to change those numbers so that all of the data that we've entered into the data table is visible. And the rule we've taught you guys is that you want the x-axis or the y-axis to go up to twice the largest x or y value shown in the data table. So if you go back to the left column and look in the T column of the data table, you can see that the biggest value for time for this data set is 30, okay? That means to adjust your scale to make the data show up, you need to change the number after the X to twice 30 or 60, okay? The number to the right, or sorry, to the left of the X is always going to be in some number between -2 and -5. That's not so important. That really doesn't matter. What really matters is the number to the right. That's going to give you the upper bound of your scale, and that's the number you want to change. And for the Y, if you look in the D column over here on the left, the biggest Y value is 90. So you want to change that number to the right of the Y to twice 90 or 180, okay? Then click anywhere else on your screen. The window will close and you can see both axes are labeled and all of our data points are shown. Now what I'm going to do is I'm going to take my cursor, I'm going to click and pull up to the right and up to move my graph up a little bit and drop my labels below and to the left of each axis. Okay, so that's how you, number 1, label your axes, and number 2, adjust the scale, again, the range of numbers shown on each axis so that all your data points are shown And the biggest value on each axis is twice the biggest value shown in your data table. Okay? Now, if I were doing this in an assignment, I would immediately at this point hit save. Okay? That means the work I've done so far is saved online, and if I go back to it, it will be there waiting for me. All right, now we're going to scroll down below the data table in our left column, excuse me, and it says use the slider to change the A value and find a line that best fits the data. Right here you can see A equals 0, and you have a little blue dot. If you click and drag this dot, it moves a number of different lines onto your graph, and you can match one of those lines to your data. So I'm going to click and drag. There's a blue one. That doesn't look like a very good fit. There's a red one and a green one and a purple one, and it looks, if I keep on dragging, right there is the line that best fits my data. Now, the key here is that the lines are color-coded, and you can see that each of these 4 equations in our left column over here has a color associated with it, which means that this equation right here, D equals AT, which is red, matches this line on your graph. So since the D equals AT red line best fits your data, we can get rid of the other lines by clicking on the X's here and removing them from our graph. Okay? Now, we have a graph showing all of our data points, axes are labeled, and we have a line of best fit going through our data points, and that line of best fits corresponds with an equation. Distance is equal to some number A, in this case 3, multiplied by time, that best describes the mathematical relationship for distance and time for this car driving down Lombard. Okay? And if you recall, that number A for a linear distance time graph is the speed or velocity of the object. It's the same as the rate of change. So we have identified here not only an equation that fits, but the speed of the object that produced the data we are graphing. Okay, I hope that helps. Thank you very much.